guys, welcome to Algebra Lesson 13. This is your last video lesson for the week. Woohoo! Give a cheer. All right, we are talking about algebraic expressions, and I don't remember the exact, evaluation of algebraic expressions. Okay, so let's get started. First of all, I want to point out this little section of words up here at the top in brown. It says numerical expression or numeral. All of these numbers, 7, 14 divided by 2, 4 plus 3, we call those numerical expressions or numerals. They represent a number. Every number that they represent has a value. Since these all represent, really, they represent the number 7. It's here 7, 14 divided by 2 is 7, 4 plus 3 is 7. They all represent a 7. So their value, therefore, is 7. That would be the value of these numerals, okay? When we have not just numbers, but letters as well, we don't just call it a numerical expression. It becomes an algebraic expression, also sometimes known as a mathematical expression, but we'll refer to it as an algebraic expression. So an algebraic expression looks something like this: 4 plus x. It doesn't have to be a number plus a letter, but it has a letter in it. An unknown or a variable is what we call that letter. Because the value of this expression varies, it changes based on this particular variable, based on the letter, the x, whatever the value of x is. So let's say that if x equals 5, I'm going to erase my question mark and I'm going to say that x equals 5. Then that's going to give this expression a value based on putting the 5 in place of the x, and you would get 9. But let's say that my x changed, and it's not 5. Let's say my x is instead 11. Well, then I put 11 in place of the x, and I get 15. So the value of your expression changes based on the value of your variable, the value of your letter. So when I'm working with letters, I can use the same symbols to indicate our various operations: addition, subtraction, multiplication, division. I use the same exact symbols that I use when I am just working with numbers. There's only one difference, and that's this right here. If I am multiplying a number and a letter, I can just put them right next to each other. 4x, that means 4 times x. Okay, so it would be the same as if I put a multiplication symbol in there, 4 times x. But I can put them right next to each other. It saves me time, saves me space, saves me extra symbols, and I know that I'm doing multiplication. We can't do that with numbers. 4, 5. We would read that 45, right? Not 4 times 5. So we can only do that with a number and a letter, but not with two numbers. Okay? Let's talk about evaluating algebraic expressions. When you are given something like this, x, y, m, that means I'm multiplying the value of x times the value of y times the value of m. To evaluate this, I need to know what those letters stand for. So if I say evaluate this if, now let me look at my book, if x is 1, y is 2, and m is 3. Then I put my numbers that these letters stand for in place of the letter. So I have 1 times 2 times 3. And then I multiply it across. 1 times 2 is 2, times 3 is 6. And that's your answer. Look at this one. I have 4x plus mx. So I need to put in the correct value for those. Let's say that my x is equal to 3. Write that up here. And my m is equal to 5. Your problem will always tell you what these are equal to. I just didn't have time or space to write it on the board before I started. So if my x equals 3 and my m equals 5, I need to evaluate my expression like this. I would say that this is 4 times 3, because the x stands for 3. Sorry, I know I turned my back on you guys a lot. Plus, this is m is 5. Since I know that x is 3, I don't change anything and I keep it 3. Now that's a very important point, okay? Whatever x stands for in an equation, in an expression, it stands for the same number all the way through the expression. It doesn't change. One variable always has one number assigned to it. It doesn't change throughout your expression, okay? So whatever value is assigned to that variable is going to be the value for that variable throughout the whole problem. So now I do my multiplication. 4 times 3 is 12. 5 times 3 is 15. Add it together, and 27 is your answer. Okay, so let's do a couple more examples. If I want to find the value of 4yz minus 5 when x is equal to 4, not 4. Y is equal to 2 and z is equal to 10. Sorry, I got lost on my book. Okay, so y is equal to 2 and z is equal to 10 in this case. So that means I need to change y out for 2. So I have 4 times 2, z out for 10, minus 5. Multiply these across. 4 times 2 is 8, times 10 is 80, minus 5 is 75. And there's your answer. Okay, let's do the same with our next problem, y minus z. Y this time is negative 2 and z is negative 6. So I have to be careful. I'm going to put these in parentheses to guard my negatives. So y is negative 2 minus z is negative 6. I'm putting this in parentheses so I don't accidentally lose it and think that my minus sign was my negative. Okay, it is minus a negative 6, not minus 6. You have to be careful. So negative 2 minus a negative 6. When we add a negative, remember that's the same as adding a when we subtract a negative, it's the same as adding a positive. That's what this becomes, an adding now, not just subtracting. So I have negative 2 plus a 6, which would be positive 4. Very good. All right, let's look at this one. Negative x minus negative a plus b. Okay, once we get into this territory of negatives, I have to be very, very careful. Okay, so you need to be very meticulous, very organized, very neat in your work. So I have x equals 2, right up here. A equals negative 4, and b equals negative 6. So now I'm going to start putting those numbers into my problem in the place of their letters. So here I have a negative x, so that's a negative 2. I'm going to just put some parentheses around it to guard it. Minus, now I have negative a. A is already a negative 4, so does that mean I just write negative 4 like this? No, I cannot do that because it's a negative, it's the opposite of, remember negative means the opposite of whatever a is. A is negative 4, so that means it's the negative of negative 4. Again, that's why we need our parentheses to make sure that we guard that negative that we already have. Plus b, and b is a negative 6. Okay, so now I can solve my problem. Negative 2 minus the opposite of negative 4 plus 6. What's the opposite of negative 4? Positive 4, right? Because we have two negatives. It's like you're multiplying a negative times a negative. So it's positive 4 plus a negative 6. What's positive 4 plus negative 6? Negative 2. So I have negative 2 minus a negative 2. Well, remember, anytime that we have subtraction of a negative, that's the same as adding. So it's like this becomes a big addition sign. So I have negative 2 plus 2. Cancels each other out, right? And you get a 0 as your answer. Okay. Next I have negative n plus x minus a plus mx. So I'm going to write down their values over here. That m is equal to 2. X is equal to negative 3. And a is equal to negative 4. Okay? Now I'm going to plug and play. Here we go. So I have a negative 2 plus negative 3 times negative 4 plus 2 times negative 3. I know it seems a lot bigger, seems a little bit more complicated. Just make sure that you're paying careful attention to your parentheses and your negatives. So I'm going to start over here. I have negative 2 plus negative 3. First of all, let's start here. What's 2 plus negative 3? Negative 1, remember? 3 minus 2 is 1. Absolute value of 3 is greater, so it's negative. Negative 1. What's the opposite of negative 1? 1. So this is 1. Times, what is the opposite of negative 4? Positive 4. Plus 2 times negative 3? Negative 6. Now notice 1 times whatever this answer is. I know that 1 times anything is going to be itself, so I can get rid of the 1. Okay? Because 1 times whatever this answer is will be whatever this answer is. So it's like it's not even there. So I have 4 plus negative 6. Okay, subtract, take the sign of the absolute sign of the number with the larger absolute value. All right, that will be the negative. So it's a negative 2 is your answer. Alrighty, do your practice really quickly. Okay, letter A, positive 4. Positive 4. Letter B, negative 16. Letter C, negative 19. And letter D, 44. Okay, if you are confused about this, watch the next part of the video. If not, go ahead and do your lesson.